So in this example, we have a steel ball swinging on the end of a rigid steel rod with characteristics as shown. I want the magnitude of the tension in the rod at the top, A, and at the bottom, B. So this rod has two forces that influence its tension. One is the force of gravity on the ball, and the other is the centripetal force on the ball. So to calculate out the force of gravity, we can use Newton's second law, F equals ma, but specifically F equals mg, because the acceleration is due to gravity. Mass of 3.5 kgs, acceleration due to gravity of 9.8 meters per second squared. Working that out to 2 sig figs means we have a 35 Newton force due to gravity, and that is 34 newtons down. The centripetal force on this ball, we need to look at the information given to us. We have the mass of 3.5 kgs. We have a radius of 1.2 meters. And a frequency of 1.0 hertz. Looking at those variables and the centripetal force equations that we have, the one that works would be Fc equals 4 pi squared mRF squared substituting in 3.5 kgs for the mass, 1.2 meters, and 1.0 hertz, which is squared. Working that out gives us a centripetal force of 166 newtons. Now that force applies at all points on this ball's motion. So I'm not going to assign it a direction yet, because that direction will change based on the position that it's at. So at position A, which I'm just going to sketch out not very well, but at position A, the ball's at the top. So at position A, the centripetal force is acting down. Gravity is also acting down. But the tension in the rod is what is used to overcome the centripetal force. So the tension in the rod is acting up. So to find the total tension at A, we have 166 newtons, which is now acting up, plus our 34 newtons of gravity, which is acting down. We need to change the sign to get consistent directions. Which will give us a tension of 132 newtons at position A. Position B, similar, except now the ball is here. Centripetal force at B is acting up, because centripetal force always acts towards the center of the circle. Gravity is acting down. But again, we need the force of tension in the rope, which is equal and opposite to the centripetal force. So the tension in the rope will be acting down. So the total tension at point B, we would have the 166 newtons, which are now acting down, plus the 34 newtons of gravity, which are also acting down. which would mean that the tension at B is 200 newtons.